Hello everyone and welcome to Rebel Way. My name is Andrew Sutherland and today we're going to be creating this earthquake effect. And this effect is really comprised of a few things. Some ground destruction, there's some debris, there's smoke, there's this curb destruction, the ground destruction, and some cars. But what we're going to focus on today is just the ground destruction, and then in the next tutorial we'll take a look at the curb and all the other elements. And the final scene was provided to us by an effects artist, and it's quite complicated. I'm going to go over the final project, but what I wanted to show here first is the simplest technique I can think of possible to doing some sort of ground destruction. And if we can, if everybody could do that, then I think it's the more complicated version is going to make a lot more sense. And it's just nice to have a really simple setup. I tend to think that if you can do something simply, that's possibly the best way to go. So starting in a fresh Houdini scene, I'm just going to press D on my keyboard and I'm going to change this to dark, and I'm going to put down a geometry, and then I'm going to dive inside and I'm going to put down a grid. And let's increase our divisions, something like that, just so that we've got a nice uniform thing to work with. And let's maybe even increase the size to 20 by 20, and let's draw with a curve where our destruction wants to take place. And if we just draw at this point, this point is going to float up in the air. So what I like to do is I like to come over to the top view, and I just find that if I click a few points here and right click and say finish adding points, jump back to the perspective, you can see it's all sitting perfectly flat. So that's why I like to jump to the top view to do that. And let's put down a resample. As you can see, let's just tick this on. You can see there's a point, and after we resample, now we have a whole bunch of points. So now we've got this line, which is going to be the sort of where our destruction takes place. And in order to get this to travel, we can put down a carve node. Where is a carve? And let's tick this on. And as we animate this, you can see this sort of animates on. So let's come over to the first frame, and let's just say keyframe, set keyframe, and then let's come over to frame 48, and let's turn this down to 0. Cool. So now we've got this curve animating on. And if we want to play this in real time, let's click on this real time button, and you can see the speed of our destruction. Well, the animation of our line. And the next thing we want to do is let's put down some color onto this, because we're going to use this color to transfer onto our geometry. So this has just got the color of white, and on our grid, let's put down a color here, and let's make this black. Cool. So untick these points. And what I want to do now is I want to transfer the color from this line onto our geometry. So let's put in attribute transfer. And as you can see, it's transferred all the color, but let's come down over to our conditions and let's turn this down. And then let's change our, something like this. Cool. Something like this is fine. And if we come back up here, what we want to do is we're going to deform this this geometry. So, but we also want a rest. So we're going to store this position, and we're going to have a second position, which is, let's transform it up. So this is going to be our height. So when our earthquake takes place, this road is going to be pushed up, and we're going to push it up by this distance. So let's just say 0.8, something like that. And then let's also introduce some noise. So let's put down attribute noise, and let's put the position, and we want this to be 0 centered, and this is pretty strong, so we can turn this down. Let's try Perlin noise, and our element size, let's try increase this. Let's increase this to 5. Yeah, we can tweak these values later. Let's try something like that for now. And basically this is going to be how our pieces are sort of rotated and distorted. So yeah, this is fine for now, and we're going to plug this into our rest position. And then what we want to do is we want to use this color to drive that deformation. So let's put down a point VOP, and if we take our position into position, there's not going to be any difference. But if we bind and put that rest, it's a vector, so let's change this to vector. And if we check this one, you can see it's transformed up and given this deformation. And what we can use is a mix node to mix between this position and this position, and based on the color, you can see what we get here. So now it's only deforming where we have that color. And as this animates on, let's put just down an attribute delete, so we can delete the color and see this a bit better. Cool. Cool. And if you inverted this, so if you were to go minus 0.8, you could do like something like footsteps in the snow. Yeah, something like that. Or car tires. But for now, we want to just form this up. It's maybe a bit too much. Let's try 0.5. Cool. Cool. So this is going to be our displacement. And what we want to do next is we want to take this grid. Let's just put down a null. Let's put down a poly extrude. Something like this. Let's output back so that, you know, we've got this watertight container. Let's take this with our color on it. So let's put down a null here. Let's just call this out color. Copy this. Let's put an object in merge. Paste this in here. So now we've got that here, and we want to, you know, this is still animating on. So let's time freeze this. The time shift. Let's come to make sure it's complete. Delete channels. So now this is just stuck. And let's scatter points. And let's scatter on the color. That way we're going to have lots of points here and no points there. So reduce our number of points. Let's turn relax iterations off. And then let's make a version that scatters on everything. So we can just scatter on the whole grid. Turn relax iterations off. Reduce this. And let's merge these together. And these are going to be our points that we're going to use to fracture our geometry. So from there we can put down a RBD material fracture node. And we plug this into our extra Voronoi fracture. Well, it says extra points. See, I don't think this is working just yet. And we need to tick on input points. And now you can see that these points are driving this fracture. Cool. So if we come back here and we come on to detail, let's tick on edge detail. Let's change this to wire view. Let's put down an assemble node. We need to assemble. This is going to create a name and tick on pack primitives. And let's put down an exploded view. Cool, so let's jump back and we can see our pieces are fractured quite nicely. Cool. And so now all we need to do is we need to deform these pieces with this, and the way we're going to do that is with a point deform. And so this requires 3 inputs. It requires our mesh to deform, which is our fractured pieces, a rest position, which is just going to be our grid, and our deformed points, which is going to be this. Cool. Maybe it'll make a bit more sense if I take the rest from here, because it's same thing really. And as you can see, we now have this cool earthquake effect. The only problem I see here is that this sort of pops on. And so the easiest way to fix that is, of course, just blend shape. So let's blend between this position and this position. As you can see, there's our pop. So all we need to do is animate so keyframe, set animation, and if we come here and we set this to on, now you can see this gradually cracks on. Cool, so that is our earthquake effect. And what we could do is we could obviously just layer up an actual RBD, so we could make maybe another, this could be our ground, and we could fracture another thin piece of geometry on top of this, and you could get that to be an actual RBD sim. And I believe that's what we're doing something similar in the final project. This is looking pretty cool. But I think this looks pretty good. You could obviously just play through timing and dial this in. But I'm pretty happy with this result. So let's just save this. Let's call this ground destruction live. Let's save. Next up, let's take a look at the debris. So we want to emit some debris from this. I think let's just cache this to disk. So let's put down a file cache node. Personally, I like to make these red, so when I open up a project, I know to just come over and cache these, and I like going to explicit, and I'm going to load this here. So this is my hard drive, this is the name of the folder, and then this $OS is going to pull this name. So let's call this cache fake RBD, and it's yeah, frame range, this is all good. Cool. So let's just save that to disk. Cool. And this is packed geometry, so let's unpack it. We could have maybe unpacked and then cached, but doesn't matter. So we've unpacked that. Let's trail this so we can compute our velocity. And let's say compute velocity. And let's create some collisions. So let's put a null. And this will be our collision geo. And let's create a VDB version. So VDB from polygons. Let's lower this to something like 0.5. And let's call this col VDB. And we can cache this to disk. Let's call this col geo. And this will be col VDB. Save this to disk. Let's cache this to disk. Cool, and then let's put down our handy debris source. This is obviously going to do a whole lot for us. And as you can see, we've got points everywhere, but we just need points here. So if we scroll down and we say remove, and let's try remove n from life 2. Cool, and these points are staying on pretty long. So let's try reducing our lifespan, because we just want debris to pop on and off. Yeah, something like that's cool. Let's reduce our number of points significantly, something like 30. Set that recache. Lifespan even lower, 1. Cool. Let's, because we're going to copy geometry onto this, let's randomize the p-scale. Let's randomize the normal. That just means that basically this is going to randomize the orientation. And then let's copy the points. And let's just put down a box. Let's take a look at our box. Let's make this a uniform scale of 0.1. Let's give this way more divisions, so that if we put it on a mountain, let's press F on our keyboard. Let's reduce the size and Y. Something like this is fine for now. We're gonna in the final scene, we're gonna take a look at instancing different pieces onto geometry, and it's honestly it's a bit complicated, but in the Star Wars Lightning tutorial I show a pretty easy way of just creating IDs on random pieces or random geometry, and then assigning those that ID to your scattered points, and then it'll copy across. So I highly recommend the technique in that Lightning tutorial. But like I said, we do have a more complicated way of doing it in the overview project. But yeah, it's a bit difficult to explain. It's basically the same thing where you're copying IDs onto the points and geometry, and then copying them using the ID attribute. But for now, I'm just going to copy this one piece onto all our points. Let's hit F again. And it's randomized this p-scale between 0.2 and 1. Let's take a look at our sim. Cool. So for now, this is just our source. And let's put down a DOP. Let's put down a DOP network. Make sure we save. Let's take this into our first context geometry and dive inside. We're obviously going to need a gravity. We're going to need a static object for our collisions. A ground, just so that we have a floor. We can merge these. We're going to use a multi-solver. Make sure our gravity comes in here. A RBD packed object. A RBD packed object. A bullet solver. And a pop source. Cool. So under physical, I'm just going to make this 100. I'm going to lower the bounce to 0.1. And these are just some settings that I've already dialed in. So we don't have to go over this again and tweak. On my bullet solver, you notice this is actually empty because we're going to pull in the data from here. So we want to say emission or geometry. And we want to set this to use first context geometry. We're going to set our life expectancy high. We're going to inherit the velocity, so we actually want to turn this up a bit. This is the setting I ended up. It's just that, you know, I wanted my particles, my debris to shoot up first and then come down. So that velocity is coming from here. Well, it's inheriting the velocity on the points, and that's upward. And here we're just multiplying it by 7.5. On our bullet solver, everything is standard, and then on our static object, we want to tick on use deforming objects, use on deforming geometry because our collisions are changing. And under collision, we want to come over to volume sample, and let's copy, this is our geo, so copy that, dive back. And our SOP path, we can copy that, and on our proxy volume, let's copy that again, and then look for the VDB. Cool. And this is going to wrap all our geometry, and what we actually want to do, cool, let's just try this. Let's try this first. Okay. And we're getting this issue, and I think it's because our geometry is not packed. So on here, let's tick on pack an instance. And now it should work. Yep. Let's just tick save quickly. You see our debris is really shooting off, so I think we need to either lower that inherent velocity or introduce some pop drag. So let's do that. Let's put down a pop drag, and let's lower this to 0.1. And this is looking pretty cool. Let's just make sure that our collisions are in fact working properly. And you see that they're not. Let me just check. Let's just have a look at our VDB here. These are sort of sitting above and they're falling through the cracks. That's fine. Okay, let's come over here. Let's try changing. Let's come over to this bullet data and let's change this to concave. Let's just take a look. This seems to be working better. Yeah, cool. Let's tick save again. And then let's cache this out. So we need a DOP import. We want to import our DOP network. And then we want to mask this by our RBD packed object. Cool. And let's cache this to disk. Let's call this debris cache. Cool, so I've just run the sim, and as you can see, this is our result. The only thing I introduced was a bit of pop, drag, spin, so that they don't spin as crazily, and we could obviously tone down the amount of debris that we see here, but I'm pretty happy with this. So if I just show you the changes, I just added this pop, drag, spin, and I think I also added I increased this friction by 5. Yeah, so that's all good. And then I cache this out to disk. I'm just deleting all the attributes except for the position and the velocity, and then I'm merging it with our ground. So that is my very quick and basic version of doing this. And now we can jump into the final scene, and we can see how it was done in that project. Cool. And of course you can also add the smoke, but I'll cover that in the overview project. So jumping into Houdini, we can first take a look at this ground destruction. And the first thing we have is just a plain, we have a texture on this, but you know, this is for rendering later. And we're just transforming this up. From there, we're going to extrude this. So you can see this is now just, we're giving some dimensionality to that by just extruding this by -3. And we've got output back tick faces on. So this is just going to make sure that this is a closed box. And you can see this is all purple. And that just means that our normals are pointing in the opposite direction. So this is, you know, like the outside faces are pointing inwards, and that's incorrect. What we need to do is reverse those with a reverse node, and you can see we now have our box. From there, we're just using an UV unwrap to give this some UVs. As you can see, you can tile that up. Well, change the size with the spacing. And what we want to do is we want to group our edges. So using this include edges, and enabling this, we can select just our edges, and that way when we remesh, we can retain this sharp edge. So next up obviously is the remesh, and you can see hard edge group is edges, and if I were to disable this, you'll see how this is going to get rounded out, and that's not what we want. We want to retain those edges, so we have this ticked on. So as for our remesh, I'm just going to make sure that not missing any information, and from here we're just going to group this top part, and we're going to call this road, and again a UV so we can texture that differently. And on this side we're importing this curb, And we're going to take a look at this curve a little bit more in detail later, but for now you can just think of these as these shapes with some extrusion. Again, they're all purple, so we know what to do. We need to reverse the normals, and same thing again, selecting the edges, remeshing, and we're just going to cache that out to disk. And from here we're just going to subtract those shapes from our road, and we're using a boolean to do that. So you can see here, and we're outputting these groups here. So if we tick here, you can see we now have these groups, and that's just based on this boolean. From there we can just put down a color, and we can give our ground some sort of like tarmac color, and we can give it some normals. So with this post compute normals, just going to reset our normals. From there we're going to create this cutout, and this is where our instructions are going to take place. So here we're just using this curve node to draw this shape. So if you can come over to this button here, and you can just set out some points, and this is going to give us this shape here. We're going to reverse this, and here we're going to resample. So if we come over to our points, we can see we've got a lot more points here. So before the reshape, and now we've got an even distribution, and we've got a hell of a lot more points. And this VOP is just going to be some noise to displace this a bit more organically, so we've got this nice breakup. And if we dive inside, we're just taking the position, we're adding this noise, and we're adding it to the position. So this is just going to add some values back and forth, and that's how we get this this nice organic breakup. You can obviously play with the amplitude, you get the idea, and the frequency size, but this is the look that we want. So from there we have this wrangle, and we're just setting the position of the Y to 0. So we're making sure that these points are all at 0. They are already, actually no, they're not. I see that this noise is pushing them up and down, so this is going to reset that. You could also use a transform node and just zero out the Y. That's exactly what we're doing here. From there we're going to fuse this and just make sure that that our lines are all connected. So this is just some housekeeping, and here we're reversing it again. I'm not sure why it was reversed here in the first place, but yeah, you get the idea. And from here we're extruding, so we've got some depth, and we're just transforming this down into place, and we're putting a null so we can read this into our simulation. So in this one we're extruding because we want to shrink this in. You can see we can expand and shrink because we want to just create a border here, and so that's what we're going to be doing here. So maybe that's why we've got the reverse up here. No, okay, I'm not so sure what that reverse is for, but anyway, same again, we're just going to noise up those points, where we're setting the Y to 0, so everything's sitting flush. Some housekeeping, and we're reversing it again. From here we're extruding once again and transforming it into place, and then putting it out now.
So next up, we're going to draw some lines that we can use to fracture this geometry. And for that, we can use a curve node once again. And one thing I forgot to mention is when you're drawing these curves, you should probably come over to top view, something like this. And then, as you can see, when you draw these lines, they're going to sit at point 0, a 0 along the Y. And in order to get that, I always just come over to here and I just go to the top view. So yeah, I'm just gonna undo that, and we need to resample these points. So if we check our points before, there's our points, and now we're resampling, so we keep throwing a lot more points at these lines. And those are our settings. Let's jump back to perspective view, and from there we're going to put down a noise again, exactly the same. We're just adding this noise to the position and then exporting that as P, so that's going to give us a bit more detail. Next up we have this attribute VOP, and we're just making sure that these our points are sitting perfectly on 0, because like I said, we use this noise and that's going to move our points up and down. So from here we're just giving these an up normal. So if we come over to our normals, let's take a look here. You can see that our normals are all along the Y, and that way when we extrude, they're just going to extrude along this direction. Without that, you can see we've got an issue. So this is our extrude. And we're just going to transform this into place so that it intersects with our ground. So just templating that, you can see our intersections. And then we need to fuse these. These are just going to snap these lines together nicely, and we're not using that merge. And over here, let's turn off this normal view. Here we're importing our ground, we're importing our piece, we're importing the inner part. So this way we can boolean this out, and then we can boolean these together, and now we just get this outer ring. So this is going to be like our border for our simulation, and this is going to be the part that we fracture. Here we're just subtracting that outside part. So now we've got the inside, and so now we've got the inside here, and we've got the outside here. So on the inside part, we're going to give this a name, and we're going to call it road. And here we're setting, here we're also giving it a part name, so a name and a part name. And here we're using these cutting planes that we created with our curve, and we're booleaning them. So this is going to shatter. So let's set to shatter. And we're creating a group called inside faces. So the inside pieces are going to be, we're going to have an attribute that we can use to control this. And you can see this is actually just a normal issue that we see here. So what we can do is we can group the outside pieces, and we can set a normal, and then we can set a normal for just the outside pieces. And now that's going to get rid of those horrible lines. But if we were to say, well, let's look at this assemble node first. So we keep creating. So if we were to put down an exploded view, you can see that our pieces are all looking good, they're all there, but when you put them together, we don't have any of those weird normal issues. I don't think those normal issues will come across in the render, but you know, can be frustrating, so let's just clean them up. And as you can see, we need this assemble node so that these pieces are treated as pieces, And this is how we're doing that. We're creating a name attribute. That's the most important thing here. Without that, we've got this issue. We tick that on. And now these are treated as pieces. So here again, we're setting that name attribute again to origin pieces. And if we delete our inside pieces, we can take a look at our inside pieces here. And this is all the pieces. It looks like one piece here, but like I said, you know, if you put the exploded view on, these are all our pieces together. Cool. Let's just expand this and let's take a look at our collisions. So next we can import this base. We're going to clip the bottom. We're going to polyfill this. So this is just going to close our gaps again. We're going to reset the normals, and then we're going to boolean this with our pieces. So we've just got this very top layer of the road. So we're going to use this collision source node, and what this is doing is it's creating a VDB version and it's creating a geometry version. So if we come over here, we can look at the geometry version, and over here this is going to give us our sign distance field for the thing, which is a VDB of our geometry. So on our node, you can see it's our geometry settings, and this is our volume settings, and the volume name is called collision. If we just use the VDB, our volume name is going to be surface, so you need to either rename it or whatnot. So, but yeah, using this collision node, it's just going to call that VDB collision. Where is it? Collision. Cool. So if we come over to this section here, what we're going to be doing here is we're going to be creating this procedural sort of earthquake here. And what we're doing is we're looping over each one of these pieces, and we're trying to see if the piece is close to this curve. So we're going to draw a curve like we did earlier along here. We're going to resample that, and we're going to animate this point here. So it draws along. And what we're doing is we're looping over these pieces, and we're using a PC find, which is going to look at the first input and then look at the position of the second input. And we're saying that if it finds a point and they're close enough to that line, then it's going to create this group called near carve. So we're grouping all the points that are closest to this carve. And then what we're going to do is create an attribute called height that we can use in our soft transform to sort of push this up and expand it in its height. So it's quite subtle here, you can see. It just grows a bit. And if we loop that over each piece, that's what this for each loop is doing. We see that we have this final result where these pieces pop on like this, and they've been pushed up. We're just going to transform this into place. And then from here we're going to create collisions like we did once again. So this is our geometry, and this is our surface field. If we come over here to this animation guide, we can see we're doing a similar thing with this for each loop. Let's take a look at the result. Pressing F on my keyboard, I can just frame this up. So you can see we're getting this nice deformation. The actual geometry is growing and stretching and being displaced. And so if we come over here, we've got that curve coming in, and we're carving it just to grow like that, as we did before. We've got our pieces, and then we're looping over each one of those pieces. And let's just take a look at this
wrangle first. So just like before, we opening up a point cloud, and we're looking at the points from here and the points on here, and we've got a search radius that we can set with this channel over here. So if you type this CHF and then put in the name of this channel and you click on this button here, it's going to create this value here. And so we've got a lookup of 7.1, and we're just looking around that distance for any neighbor points, and we're only we're considering points with a value of 1. So if we come here, we can see that we've set a value of -1, and here we're going to create here we're just declaring a variable, and then this is just checking to see if we found any points within that search radius. Then here we're retrieving the closest point on the animation line based on the point number obtained from the point cloud here. So we're trying to find the closest points to that line, and then we're setting a distance. Then we're calculating the distance between those points and the line, and then we're setting that value as this attribute distance. And if it doesn't find a point, then it's setting those values to -1. So in short, we're trying to find the closest points to that line, and we're storing the distance on an attribute called distance. And on this node, we're setting a height between a random value based on the piece, and we're fitting that between 0 and 2. So as you can see, these all kind of have slightly different heights based on the piece. And to make that a bit more explicit, I'm going to copy this. I'm going to mute this one for now. I'm going to enable this, comment that out, and I'm just going to set this to 1. Set this to set this to 1, and as you can see now, this is just changing the height like that, but we want to do this over each piece and randomize that height a bit, so that's why we have it written like this, and now we get this result. Cool. And then on this last node, this is actually where we're setting the amount of that distance. So basically this is going to set our height, and this is going to control our fall off. And then this for each loop obviously just runs over each piece. And now we have this pretty cool ground effect. So the next thing we're going to do is we're going to freeze frame this on frame 1. So we just got this static. We're creating a volume out of this with an ISO offset, and we're just going to scatter some points inside that volume. So as you can see here, we're just scattering 10,000 points, and this is our result. And what we're doing is we're going to point deform these. And so this requires 3 inputs: our moving geometry, our points, and a static version. And with that, we can then deform this. So these points are now deforming with our road. And from there, we're going to trail these so we can compute the velocity. And then we're going to rasterize the velocity. So you can see we create a field called V, and this is just based off the velocity here. So you can see the parts that are moving, we have a velocity, and we're just caching that out to disk. And here I'm just visualizing this a little bit better. So that's our velocity. Cool. And then null, so we can read this in. This section here is going to be quite straightforward. We're basically going to be preparing our geometry, and we're going to be fracturing it. So as you can see, these are all our different elements. This is just a low-res version that we can send over to the simulation. And this is our border. Cool. So let's just take a look at what we got here. We're obviously importing our ground from this out geometry, which is coming from here. Not this one. This one here. So with our name attributes. So we've got that here, and we're subtracting that. So here we've got this grid, and let's take a look at that. And we're remeshing this so that when we intersect, it's, you know, got this nice subdivided triangles. And we're basically just cutting this up here. So we can take a look here. We're just cutting this top section off like this. So we're using this to slice this top section. So if we template this, you can see how this is intersecting. We're chopping the top part off, which can be like our asphalt or, you know, gravel ground, you know, what you see on the road. Here we're creating a name again. So we're taking this on, and we're giving this group a name, a top road, and this bottom road. So as you can see, we've got those two groups, and then we're putting out a null so we can read this into our simulation later. If we come over here, you can see we're importing that again, and we're creating those curves that we extruded out. And as you can see, we're doing this again. We're fixing the normals. It's now just on our top layer. So as you can see, we're just doing that on the top level. And here we're setting the pieces to have a name attribute as well. From here, we're going to scatter some points, and we're going to feed this into this RBD material fracture, and this is going to be set to concrete. And these are our settings. No chipping. We do have some detail to give some variation on the side, so let's just take a look at that. Let's come down to the exploded view, and you can see that detail along the edges. Without that, let me just untick this. So if we turn this edge detail off, you can see it's just like a Voronoi fracture, but with this edge detail, it sort of breaks up those shapes a lot more. Cool. We're not using the constraints, but we're gonna create our own later. And from there, again, an assemble node, create a name attribute, and here we have the save to disk. We've got a group for the inside pieces, and we're gonna set a color and another color for the inside pieces so that they're darker. We're just grouping this top road again. This group is just selecting everything, and if we come over to the exploded view, we can see what we've got here. And as you can see, this is what those colors are doing on those inside faces, making those inside pieces darker. Cool. And we are merging that with this, which is our bottom. Again, those curves, we're using those to divide this. We're setting those normals again, and assemble, creating a name. Again, we're using this offset as volume fog to convert this into fog. So obviously if this is like that, you know, we're creating this as a fog. Scatter points inside. We're just setting the value to 0 here on the wire so that they're all sitting on the top. Transforming those down, using this fuse to reduce the points that are close to each other. So you can see with this on, you can reduce the points based on how close they are to each other. And then we're just going to feed this into, again, a material fracture, just like we did before. And of course, if we come down here to the exploded view, we can see what that has done. So we've got this ground breakup. This is a group for the inside faces, but they're all pretty much inside faces. Here we're grouping everything, and we're calling it inside. And here we've got just the position fitted into a ramp and exporting as color. So the deeper it goes, the we're going to get this color. So let's just come over here, say smooth shaded, and you can see the deepest part's going to be here, and then it goes all the way up to black. Here we're just going to promote the color from points to the primitives, and we're going to group this as below road. Cool. Merge that together. Again, assemble it, create name attribute, and put out a null. Moving on, next we're just going to create a low res version. So here we're importing our high res geometry. We're blasting off the top piece, and here we're blasting off the, well, I mean other way around. We're blasting away the bottom piece, and here we're blasting away the top piece, just so that we can go over these separately. And then we've got a for each loop again, and we're just reducing. Let me change my background to light quickly. You can see we're reducing the amount of polygons on each piece. So before and after, and we're running that over all the pieces. So this is our reduced poly version. Seeing a color, and we're doing that same for the top. So this is just a whole lot more optimized by reducing the poly count. Merging those together, and we're calling this our out low poly version or proxy version. Cool. Coming over here, we're importing our border, scattering points on that, fracturing this just with a standard Voronoi. So this is like a simplified version of this RBDT material fracture. And again, setting a name, packing the geometry, grouping this as border, and setting this as inactive. So our simulation is going to look for active points and inactive points, and this is set to 0, so these are effectively inactive. And if we look at our exploded view, we can have a look at that border. Cool. So we're going to take a look at these constraints now, and in the original file this was done in a way that I thought was just a bit complicated. So we've used a technique that Saber came up with to make things a bit easier to explain. And as you can see here, we're importing our ground and our top layer. We're assembling these. We're giving this a group and calling it name, and here we're setting this to active. And over here, this is where we're importing the geometry again. We're using this blast node to isolate just the top part, and on this side to isolate just the bottom part. And what we're going to do now is run this over with a connect adjacent pieces. But this connect adjacent pieces is going to run over the name, but it's going to delete our origin name. So if we come look here, you can see we've got that origin name, and now it's gone. So what we're going to do is attribute transfer that origin name back onto our primitives here. So as you can see, now we have that there, and then we're going to promote this to points. So now we have the name and the origin name on just the points, and then we can use this wrangle, and this wrangle you can see is going to delete these primitives where the name is different. So it's going to look at each point. It's going to get the first point, 0, and query the name origin attribute and store that name in a string. And then it's going to get the second input, query the same attribute and store its name as name1. And then this lets us isolate or delete in between primitives where the name is different. So it's going to look at this point, and it's going to look at this point, and in this case the first point and the second point are going to be different. The name is going to be different, so it's going to delete those points, those primitives. And here and here is the point is going to be the same, so it's not going to delete those primitives. And if you want to reverse this, you can just type in equals, and this is going to give us the where the name is the same. So that is how we're creating this clustering. From there, we're just faceting these so we can uniqueify the points, and then we can scale them down to a point. So if you see the scale back up to 1, you can see how it was, and we're scaling this down to 0. And they're just now points. And the same process for the top part. And on the road name, this is also again the same, except we're just inversing this. So from that to there. So it's the same thing. This is just done that more complicated way where we're concatenating the names and looking at it's a bit complicated to explain. This technique is the exact same thing. It's just done simpler, and the only thing you need to do is you need to transfer the name, because this is going to delete it, transfer it, and you promote it to points. And that's it. So yeah, this is all the same stuff. This is for our outside, and this is for our inside. Cool. So that's the constraints. So from here, we're going to read in our constraints. The reason I've disabled these is that we do have other constraints from the curb that we're going to introduce later, but I wanted to break this tutorial up to be a bit more manageable. So we're going to cover the ground now, then we'll cover the curb, and then we'll cover all the other aspects. So but for now, I've just disabled this because this is what we've got currently. So these are all our constraints, and you can see they've all been scaled down to points. This is what we're going to use. And then we have our DOP network where we're going to run the simulation. Same thing again, some of these have been disabled because we're not using them yet. Oh, and this main constraint, this is going to be like an extra layer. This is going to be an extra layer of constraint that's going to hold everything together. So we are reading in the constraints from here, but this overall layer is going to keep things contained. So for instance, like if we were to just take a look at what this constraint is actually doing for our sim, let's turn this off. Let's actually just disconnect this layer. So let's take a look at our simulation. As you can see, our pieces are just flying away crazy, but if we add this overall layer, you can see it's going to be confined. Cool. So if we come down to our main simulation area, so I've just disabled several things in this network that we haven't covered yet, and we're just going to deal with this road. And if we take a look at our result, this is when our velocity gets introduced, and that's going to break this apart, this really nice destruction effect. And the velocity is coming from here, so this is the main thing that's going to create this displacement. So without this, you see, we're not going to get anything. Yeah, so it's that force, this velocity that we're introducing into the sim that's going to break things apart. And that velocity is obviously coming from here. So as this travels along our road, this is what's going to break things apart. So this node here, I've just disabled it because it does work without this. But we have this out control, and that's coming from this area here. And so we're just creating a domain basically for where our simulation takes place. But like I said, when you disable it, it does work. And then I'll come back and edit something in as to why the original artist is doing this. I'm not entirely sure, but he's creating a group here. And it's creating a group here, and then we're calling this out, And then I've disabled these because these are not relevant. This is our velocity. We've got a pop, drag, spin just to prevent spinning pieces. And then we've got a pop, collisions, ignore for our boundary. So these are not going to be pushed apart. It's just, you know, it's going to contain, it's not going to be, this boundary is no longer going to be part of the calculation. Then our pieces, this is our road geometry and our border, our rigid body solver. These are our settings. Here are our constraints. We're reading in all our constraints. And here we have our conditions. So here we're running over the constraint called ground hard. And you can see that if we have an angle that is greater than 0.15, then we're going to delete those constraints. So they just become non-existent. So that's what's happening on this one. And here, same thing, similar thing this time on the ground curb, and this is based on the distance. So if the distance is greater than 0.2, then those constraints get deleted once again. So those are our two conditions. And if you watch our destruction tutorial on the Star Wars 8080, you can see, you know, I was doing the same thing, but on the new side effects tools. This is just you know, doing it in a wrangle, but it's the same thing that we did in that previous tutorial where we just set up a few rules for braking, and so that's what we've got here. Then of course we've got a gravity, and we've got a ground plane, and then we're just sending that out. So make sure you watch that tutorial on the 8080 because this will become a lot more familiar once you've watched that slightly more basic tutorial on RBD, and hopefully it'll make this whole process make a lot more sense. So next up, we're just going to cache this to disk, saving this out to disk, and let's import it here. And we don't need this, but we're just deleting anything that is not part of the road. It's not doing anything. And here we're going to create our, well, this is our geometry and this is our VDB version. So we're just going to need this because we're going to do debris and we're going to do some smoke, and we want this to collide with those simulations. So next up is the smoke. And we're importing our geometry. We're deleting anything that is not part of our sim. Again, this is no longer needed. And here we're sourcing debris with a debris source. And this is just going to look at a few conditions, and it's going to scatter points on our inside faces. So this node is just doing a lot for us, as you can see here. And I just want to cache it out to disk so that we can scrub through nice and fast. Here we have an object merge, although we can just take it straight from here. And using a pyro source to set some density and some temperature onto those points. So if we take a look at those points, these are attributes, but we need density and temperature. So if we use a pyro source, you can see we now have density and temperature on those. And so when we rasterize this and we create a volume version, we just, you know, rasterizing these attributes, we now have our density and temperature as fields. And then we can read in our collisions. So our collisions are coming from here. And then we've got this pyro solver at the SOP level. So we don't have to dive into a DOP network in this case. We're just going to use it at SOP level. So I've just made a quick fix in the scene, and I've got my collisions coming in as geometry, and I have my collisions as a STF field, so surface field here, and it's called collision. And this, we have to merge these two together because remember we prepared this with that collision source geometry. So if we come up here, let's take a look at collisions here. So this one here. So we've got our geometry and we've got our VDB version coming out of this. And we need to merge these two together and feed those into the smoke sim. So let me come back here. So I'm reading in the geo, I'm reading in the VDB, and then I'm merging them, and then that comes into here. So we need this collision, and we need the geometry version. And onto our pyro source, we can just take a look at our settings. This our voxel scale is 0.5, our time scale is 0.5, and we could set a maximum balance here if we wanted to make sure that, you know, that our sim doesn't get too large. But in this case, we've got the sparse on, and this is perfectly fine. Our collisions, that's set up here, and we've also got a close below, meaning that nothing's going to go below 0. And for our source, we're reading in just the density and the temperature. And our temperature, and that's set to 50, and a density of 1. And we're not using velocity this time, so that's fine. Cool. And then on a shape, we actually have negative buoyancy because this is dust. It's not smoke, so we actually wanted to move down a bit. And a disturbance is going to create some breakups on our in our smoke sim. So the disturbance is like the outside detail that we see, and the turbulence is like the internal is like an internal noise that we add to our simulation. So this is our settings. You can play with this as you can increase this or lower it. Yeah, this is going to break up overall. So basically you think of turbulence as overall breakups and disturbance as finer detail on the surface. So it's quite a simple. We're not using the fire or anything. And output, we're just outputting the density and the velocity, and I've also ticked on convert to VDB and use 16-bit float. This is just going to save some disk space. We could also resample the velocity. So let's resample this and have this set to a value of 2. And what that means is that when we cache this to disk, our velocity is going to be half the size, because it's going to be half the resolution as our density. And we can get away with this because velocity is not something that we visualize. It's, you know, it's invisible. And so I always just do this because, you know, why cache velocity to disk at high res? It's always better to just do a low res version. And as you can see, I need to recache this. As you can see, it's the same now as the density, but with this ticked on, and I cache this to disk again, we'll see that we're going to save up some disk space. Cool, so we have our smoke sim cache now, and as you can see, this velocity is now half of what it used to be, thanks to that optimization that we did here. Cool. And I've just got a volume visualization node because it's a very light dust, and just to preview it, I increase the density by 10. You can just use this as a multiplier. It's not going to actually change your simulation, and it's not going to change the cache. It's just a visualization in the viewport. So as you can see, we've got this cool smoke. Cool. If we come on down to our road debris now, we can do something similar. So we're importing that once again. Again, this is not doing anything. And we're unpacking our geometry. And here we're just isolating our top part. And we're using that debris source once again. So as this breaks apart, we're going to scatter points. And I've cached that to this, so we can just take a look at that. Cool. And these are our settings for our debris source. They just have, you know, a life and an age attribute. And we can use this to source our debris. From here, we just, I suppose we didn't need to even tick these on because here we're just deleting them anyway. So we just have position, velocity, and normal. And here we're using this to remove points randomly. So this is a nice expression just to reduce the number of points. Very nice control. And here we're using that again to remove points even further. And if we take a look at our velocity, you can see these are pointing up. And now we're reversing them. So they're going to shoot downwards. And I believe on here, doing a similar thing. And we're also inverting the velocities. And here what we're going to do, we're creating an attribute so that we can copy geometry onto these pieces at a later stage. You can also take a look at, I did a tutorial on lightning effects, like a sort of Star Wars scene, and we also did something similar where we created an ID on the points and then an ID on our geometry, and then we copied the corresponding geometry to those points. And I quite like how it was done in the Star Wars tutorials, a bit, you know, easier to follow. But it's the exact same sort of concepts. So here we just putting on attribute randomize, and this is going to randomize our particle scale between 0.1 and 0.5. We can't see that here, but if we put down a copy to points, and we were to connect this, I'm just going to say pack an instance, although we don't have a lot of points, just good practice. You can see we've got some randomization on our particle scale. Cool. I'm just, when I increase this, I'm basically just multiplying that up, but this is a realistic, this is a good representation of the actual particle size currently. From here, we're randomizing the normal, and that just means that when we do copy to the points, that the orientation is going to be randomized because it uses the normal to orient how we copy pieces. So if we were to, like, instead of putting a sphere, let's put something like let's put a tube, let's put a box. And let's just increase the size on Y. And as you can see, these are all going to be oriented the same way. Sorry, I'm back. I just had a power cut, but I was explaining how these points, these boxes are copied onto each point, and they inherit the way that they are positioned is based on the normal. So the normal for all of these is pointing, you know, this way, and there's a little bit of randomization in these normals, but not nearly enough. And if we were to introduce this randomization, now we can see we're getting something a lot more organic looking, and this is the sort of thing that we want on our debris. So we're going to instance some geometry. Like I said, we're going to fracture a piece of geometry, and we're going to get a whole bunch of pieces, and we're going to use this name piece to copy those pieces onto the debris. And like I said, I showed a very similar approach in the Star Wars lightning tutorial that is a little bit easier than what we've got here. So you might want to take a look at that. But essentially, this is what we're doing. We're randomizing the normals on this. And this is again for the instancing path. And again, this is so that we create a name so we can copy different debris onto each one of these points. And then we're preparing this for a DOP simulation. So if we dive inside, it's just a very simple sim. And we don't need any of this stuff. But basically, this is our collisions are coming in here. We've got a gravity. Our gravity is increased quite a bit here. And our points are coming in through here on our DOP sim. And that's it for the sim side of our, but that's it for our ground.